Lesson 1, 5 equations. So we are going to talk about equations in a lot of detail today. The objective of today's lesson is to solve equations with one variable and also to solve equations with two variables. Mainly today, you're going to look at equations that have what's called replacement sets. You really don't have to do a lot of solving that you might expect, but that is definitely coming. So equation, by definition, has an equal sign. It's just not an expression anymore. It's actually an equation. It's called an open sentence when it's an equation that has a variable. It's open because it's not completely solved. There's still a variable involved. To solve the equation, you find the value of the variable that makes the equation true. So you're solving it. Let's say there's an x in there. You want to get to the point where you know that x really is equal to maybe 5 or whatever value it is. That's called solving the equation. We will use a replacement set. So what happens with that? They give you this replacement set. It's a list of numbers. You plug all of those numbers into the equation to see if it makes the left side equal the right side. And if it does, that number must go in the solution set. The solution set is the set of all values that make the sentence true. Now, I am going to tell you this. Because they are equations, there should only be one answer that would make that variable true. There's a little exception to that at the end. You do the same kind of thing when we talk about inequalities coming up, and then you're going to have a whole set for the solution. But for right now, you got to go through the whole process of using that replacement set and then writing the solution set for the answer. So let me show you what we're talking about here. Let's look at this first example. So find the solution set for 4a plus 7 equals 23. That's the equation. They give us the replacement set of 2, 3, 4, 5, and 6. So I'm going to do 5 parts to this. And here's what we mean. You're going to take 2 first of all, and you're going to go 4 times 2 plus 7. And you're going to see what that equals. If it equals 23, then definitely that would be your solution for the solution set. But 4 times 2 plus 7, what is that? 15. So that one doesn't work. Then you try 3. So 4 times 3 plus 7. What's that one? 19 definitely does not work. 4 times 4 plus 7. And what's that? 23. So I'm going to put a check mark by that because that does equal the 23, and that's what our goal is. So 4 times 5 plus 7? 27. That one doesn't work. And 4 times 6 plus 7, which is 31. So that one doesn't work. What you would now do, see the directions, how it says solution set. Anytime you have to answer with a set, you got to use set notation. That would mean this stuff right here. And if you can't make that symbol, don't freak out. Just do the best you can. You put in which one from the replacement set works, which would be 4. And this is now officially your solution set. Okay, that's what you would put in there. Ben?
Why can't you just stop at 4?
Well, you know what? Kids have asked me that for years. And what they want you to do is, just in case, Ben, you messed up on 4 and it really wasn't 23, if you got down and let's say that really 6 was the answer, then you worked it out and you're like, oh, I messed up on that one. You need to go back and check your answer, because if you come up with 2 with the same thing, you could have made an error in calculation. Okay, that's the main reason. That's the main reason, just to kind of check yourself. Okay, because they may not be as simple as 4a plus 7 equals 23 too. All right, any other questions? But that was a good one. Yes? Well, because that's coming later, we're just kind of leading in so that you know what replacement set means and what solution set means. Okay, we're going to get to that, Jared, where we will just solve it. We won't use these sets. I think you'll find that because they give you the replacement set, that's really great because they've narrowed down what it is. Less likely getting it wrong because you'll have, only certain numbers to choose from for the answer. Okay. But we will get to that. Any other questions? Those were good questions. All right, let's scroll down here a little bit. So you're going to do a majority of it doing the replacement set thing, and then there's going to be some like this. Solve 3 plus 4 times the quantity 2 cubed minus 2 equals b. Now, quite honestly, here's what they have done. They have taken expressions from order of operations and stuck them in an equation equal to a variable. All that means is you're going to apply the order of operations and you're going to evaluate, you're going to find the answer and say that equals B. Because it's given in an equation, you must follow through that it equals B. So what we mean with this is you would use PEMDAS. What would be the first thing that we would need to do? Anybody want to try to do this one? Octavia, where would we start here? Yeah, so you would go ahead and write 3 plus 4, and what is 2 cubed, Octavia? 8 minus 2, and you set that equal to B every time. All right, next, Octavia, what do I do? Yeah, so 3 plus 4 times 6 equals B. All right, next. 4 times 6, and which is 24 equals B. And last, 27 equals B. Okay, 27 equals B. So basically, we've done this already. You're just using it as an equation. So you can leave it like that. Some people don't like to leave the variable on the right. They're so used to having it on the left. You can flip it around, but there really is no requirement or need to have to do that. Questions? All right, now I'm going to tell you the next two things. We have seen it already in enrichment, and I'm not really sure it's going to be in your homework today. But it is coming, and for some reason I put it on this lesson. I'm thinking because last year, or the last time I taught this, I guess, the last time I taught this, it was a different assignment. But we're going to go ahead because you will need this very soon anyway. So we're supposed to solve for n, okay, and we're going to go ahead and follow the steps that are on the poster. So, Ben, what's the first step? Step 1, distributive property. Do we have any of that?
12 plus 2, 4.
We're going to go 4n. Go ahead and distribute through there, Ben.
Minus 14.
Minus 12, and then minus 2. We're following the steps of, so distributive property first, okay? We distributed. Now distribute on the right. What's n times 6?
Where'd you get the minus?
Right here. This is a negative 1 that I am distributing through there. There is a negative, so we're distributing negative 1 through there.
Well, then n times
6n, and n times negative 2 minus 2n minus, yeah. I'm just making you follow the steps of the poster, okay? So distributive first. Now, combine like terms on the left. So are there any like terms over here on the left, Ben?
No, yeah.
Which ones?
Negative 12
Okay, so it's going to be 4n what?
minus 14.
Minus 14. Okay, are there any like terms on the right? Okay, what are we going to do? 4n minus 9. Okay, so we combined our like terms finally. Get variable on one side. So Ben, usually you go to the lowest variable. So 4n or 4n, which one's lower?
4n.
Yeah, and what do I do with that?
You subtract 4n minus
4n on both sides. And when I do that, what happens on the left?
It becomes 1,
What's 4n minus 4n?
0,
Yep, and I bring down what?
and 0. Nothing.
What do I bring down on the left, Ben?
Oh, negative 14.
Thank you. And then the equal sign, and then what happens on the right?
Negative 14 equals negative 9.
Okay, now, is that true? Does negative 14 equal negative 9?
No.
So read this right here, Ben. Read this out loud that I'm highlighting.
If variables fall out and numbers are not equal, then not possible.
Or you write empty set. Empty set. If the variables fall out and it's not equal, then you put empty set. Okay, questions about that? All right, so again at the top, if the variables fall out and the numbers are not equal, then it was empty set. Now we're going to do one last example. In the parentheses, 5 plus 8 divided by 4 plus 3k equals 3 times the quantity k plus 32 minus 89. My tree, let's follow the steps of the poster. Let's do distributive property first. What would I write?
5 plus 2.
Okay, I'm going to go ahead and leave that like this because we're not distributing that yet. Okay, we'll distribute over here on the right, which would be what?
3k
Okay, on the right, that's really not a distributive, but we do need to clean up what's in the parentheses. So what would we do with that, my tree?
5 plus 2 plus 3k equals 3k.
Yeah, I'm just going to do that. Okay, now it says combine like terms on the left. What would we combine? 5 and 2 would be what? So 7 plus 3k. And on the right, like terms, combining those, what would we have?
Or 3k plus 7.
Okay.
No, sorry.
3k plus 7. Okay. Now, step 3, get variable on one side. So you look at your variables, they're 3k and 3k.
Subtract 3k.
Yeah, subtract 3k. I think you're going to see something very similar. What would I do from left to right now below that line, my tree? 7 equals 7 because those fall out. So my tree, I want you to read this that I'm highlighting down here. What should we say?
If variables fall out and numbers are equal, then all of them.
Okay, so 7 equals 7. So on this, we're going to literally write all real numbers. Now, I will tell you, on an I-STEP test, they sometimes, instead of saying all real numbers, they say infinitely many solutions. So go ahead and write that there somewhere. Infinitely many solutions. And that just means there is more numbers than you can count, and it's everything, all real numbers. So infinitely many solutions and all real numbers.